Welcome to NSTA Web Seminars, where you can find live interactive learning at your desktop. Today's program is titled, How Do You Know That? Helping Students Write About Claims and Evidence. Our presenter this evening is Jodi Wheeler-Toppen. My name is Liz McMillan, and I'll be moderating tonight's program. Jeff Lehman is online with us to provide technical support. Web seminars are just one type of resource you can find in the NSTA Learning Center, your online portal for professional learning, and over 10,000 resources for science educators. You'll find over 3,500 of these resources are free, and you can add them to your library to access when it's convenient for you. We encourage you to join in the conversation in the community forums, where you can discuss content and classroom issues with other teachers. Our online advisors are able to help you find the information you're looking for, and you can use our free tools to help you organize your own professional development and meet your goals. It's all available at learningcenter.nsta.org. Now I'd like to introduce today's presenter, Jodi Wheeler-Toppen, a former science educator and an NSTA Press author. Welcome, Jodi. I'll hand it off to you.
Thank you, Liz, and thanks to everybody for taking time out of your night to join this. Claims and evidence and talking about it and writing about it in your classroom has been a big topic right now. I've noticed there have been several webinars on it. There's even another webinar that's going to address the similar topic in a week or so. Actually, I think in 5 days. So I'd like to do a quick poll to start out to see where you are on thinking about and using a claims and evidence approach in your classroom. So if you'll play with that poll button that's up under your name, pick I'm still learning about it. I talk about it in the context of how science works. When I talk about science with students, students are required to support claims with evidence in our discussions. They have to write about it for some or all labs, or that you do both those things, having class discussions and writing activities that revolve around making claims and supporting them with evidence. So take a minute and make a selection there. All right, it looks like just about everybody has responded. Would you close the poll and throw it up here for us?
Sorry, Jodi, I'm going to have to ask Jeff to see if he can post them. Thank you, Jeff.
Oh, okay, great. Well, good. It looks like some folks are still learning and some folks are doing quite a bit with it. The focus tonight, we're going to look at, let's see how I move to the next screen. We're going to look at first solving a murder mystery because, you know, those things need to be solved. And then we're going to look at the structure for making a claims, evidence, and reasoning type argument and what those arguments would look like in a science classroom. We're going to talk a little bit about the practical issues of helping students do this in writing as opposed to just doing it in discussion in class. And then we're going to look in at a science mystery and take a look at what it looks like when you're trying to sort out different competing claims. All right, this first activity comes from, it's adapted from George Hillick's Teaching Argument Writing, and he actually adapted it from Crime and Puzzlement, more solve them yourself picture mysteries, which was kind of a fun book if you're looking for such a thing. I like this approach to introducing claims, evidence, and reasoning because it's graphical, and it allows students to use their verbal thinking to put together the claim and the evidence and the reasoning, and their actual solving it thinking is looking at a picture. So here is a crime scene, and let me read to you what happened. Queenie Voluptuous tore out of the house after a tiff with her husband Arthur, and she went to the country club where there was a party going on. She left the club shortly before 1 in the morning and invited a few friends to follow her home and have one more drink. They got to her house about 10 minutes after Queenie did, and she met them at the door and said, "Something terrible has happened. Arthur slipped and fell on the stairs. He was coming down for another drink. He still had the glass in his hand, and I think he's dead. Oh no, what shall I do? The autopsy conducted later concluded that Arthur had died from a wound on the head and confirmed that he'd been drunk. All right, as you're looking at this picture, if you'll go over to your clip art and get something like this hand, that's a lovely hand, and point to any evidence that you think is important. We're getting a collection of things here. Love the glasses on the hallway. I'll give another minute for anybody else who wants to join in. All right, so it looks like one place that we have a lot of response is right here, and I'm not successfully drawing a circle. Let me try again. Is right here. Can I get somebody to type into chat what is significant about that piece of evidence? Let's see, maybe the thing I should do here is get, oh no, I've got some people typing, good, okay. The cup is standing up, which is, he fell down the stairs, seems very odd. Does anybody want to add to that? And it's not broken. All right, I'm going to go to, and it seems like it might be placed, and there's no spillage. Okay, I'm going to come to right here. I'm circling the arrows by the feet. And there might be fingerprints, yes. Can I get somebody to write why they feel the evidence right here at the feet is significant? On his back, feet pointed up and not down. He's not facing down. Excellent. And his trousers are not falling down. I'm going to come over and do this bunch right here. And let's get some comments. Why is there a collection of clip art on the wall? I see some people writing, or yeah. If he had fallen down, some of the wall hangings might be messed up. He didn't grab anything as he fell. Aha, and I bet that goes with this hand over here as well. All right. I'm going to go to the next screen. I'm not ignoring all, these are all, there are a few other things we could talk about too, but I'm going to hit those big three. And click to the next slide. If I click back on this, Liz, will what I've done disappear? Probably will. No, it's all still there. Oh, lovely. Okay. All right, we're going to start here. Yes, there we are with claims and evidence. And so I'm going to try to write in some of what we just described. We talked about, the first thing we talked about was his glass was not broken. Now that's our piece of evidence. And then I ask you to write why that evidence was significant. And that's essentially our reasoning. That's where we're going to explain why this is a useful thing to have seen. Oops, let me try this again. His glass was not broken, and I think we said something along the lines of we would expect his glass to be dropped if he was falling. And then we had another piece of evidence. We had the evidence that he was face up. And our reason of why that's important is that generally when people fall down the stairs, they fall face first. And the third thing that we talked about was, I'm still getting the hang of this text box tool as well, was that nothing on the wall was disturbed, and we would expect someone who is falling generally grabs for things. And note that in this place right here, I generally and generally here are both words that indicate uncertainty. And that's something that's useful to point out for students, is that there are times that scientists make commentary that has some degree of uncertainty. Okay. So ultimately, what we want to do is make a claim to answer a question. And we went ahead and gathered our evidence and told why it was important, but the reason that we're going to do that is to support a claim. Our question was Queenie telling the truth? Did Arthur trip and fall to his death? And there are two possible claims, that Queenie is, in fact, telling the truth, and Arthur tripped and fell to his death, or that Queenie is lying, and Arthur did not trip and fall to his death. And on the basis of our evidence, what claim do we want? I assume we want that all of the evidence that you gave me suggests that Queenie is lying, that Arthur did not trip and fall to his death. Well, this is something that you're using basically your common sense, and you have a general sense of what this kind of argument should look like. Let's look at it graphically, the way a claim, evidence, and reasoning argument works. You have the question, is Queenie telling the truth? And then we're going to make a claim. And can I get, well, I'll do it. That's probably easiest. We'll say Queenie is lying here. And then we can fill in our evidence here, one of our pieces of evidence, and you'll notice that the reasoning comes down here, and it points out the way that the evidence is connected to the claim. And when you're building a large argument like we were just building, you actually end up with a graphic that looks different from even that. It's this. You have a claim here that Queenie is lying, and then you have multiple pieces of evidence. Here's your evidence one about him lying face up, and here's where you talk about the reason why that matters. And then you have your evidence two that's about the glass in his hand, and here's the reason why that supports your claim. And you can see in each of these cases that the reasoning is supporting how the evidence connects to the claim. That seems very obvious in a situation like this. However, it becomes quite complicated for our students when they're working on building an argument about science. So let's take a minute here and look at these three parts in more detail, because these are the pieces that you'll want to work with students. First, the claim is the answer to the question, and that's usually the easiest for students. Students are very good at picking a claim that they would like to support. But then they need to get evidence, and that turns out to be difficult for a lot of students, because not only do they need appropriate evidence, the sort of thing that scientists use as evidence, which is not, this is something I heard somewhere, or because it looks like it might make sense. It's some sort of data, and so you work with students on recognizing what makes appropriate evidence in science. And then it has to be sufficient. It has to be enough evidence that they've essentially covered the bases of other things that might be a more valid claim. And then finally, the reasoning that we just looked at, explaining how the evidence supports the claim. And that's usually where they're going to introduce scientific principles and talk about the sort of actual science content that you're working on at the time that you're doing these activities. So this is something that's coming up in a lot of the standards and so forth right now. But let's look for a few minutes at why we're taking a claims, evidence, and reasoning approach. And the first one, and this is one that I found very powerful in my own classroom, is that when I was talking about the more generic term of conclusions and then trying to talk to them about what they should include in a conclusion section of their lab report, I got lots of different things. But once I started using these terms, terms that they have some connection to from regular life, they're a lot more successful with understanding what's going on at that portion of a lab or discussion in class. Secondly, this is how you make an argument or explanation convincing in any realm, not just in science. You make a claim, you support it with evidence, and you give reasoning to connect the evidence to the claim. This is what scientists do. And of course, this is the language that's being used in both the Common Core and the next generation science standards. So let's take a minute to look at those. The Common Core standards, this is the middle school. We'll look at a little bit about what gets added in high school later on in the presentation, but it wants them to be able to introduce a claim about a topic or issue, acknowledge and distinguish the claim from opposing claims. We'll look at that later. And they want them to be able to support the claim with logical reasoning and relevant, accurate data and evidence. They also would like for them to be able to do some writing skill type things down here, and we'll be looking at some of those in a little while. Meanwhile, in the next generation science standards, there are several of the practices that touch on this. One is that constructing explanations, and explanations are claims supported with evidence, and are engaging in argument from evidence, which can be something that happens not just when constructing explanations, but also when constructing plans for experimentation, for example. And then, of course, touching in on the Common Core, the importance of communicating information. Lots of teachers are good at doing this, but they don't see the importance of having students actually write down what they're thinking. And they don't understand why we're suddenly, in the advent of the Common Core, asking students to do a lot of writing in the science classroom. And one response to that is that writing is a key science skill. Science could not exist if it couldn't build on existing knowledge, and it can't build on existing knowledge if there's not a written record of it that allows scientists to not keep repeating the same thing over and over again, but take the next step on something that somebody has done. Oops. Writing is important because it helps students learn. It's not just a matter of having them report to you what they've found out, but the actual task of sitting down to write forces them to organize their thoughts. It helps them draw on the relationships between ideas, and it holds their ideas in place long enough for them to think about them. So they write something down, it's there in front of them, and it lets them think on it for a few minutes without having it slip out of their mind. Writing is also useful in the classroom because it gets all students to participate. So where a classroom discussion, you might pull 5, 10. If you're really good, you might get, half of your class involved. But there's always the group that's not going to participate in that in a classroom discussion. They feel like either they're quiet and shy, or they're fine to have the other people do the work for them. But in writing, all the students participate. And then writing is also useful because it helps you as the teacher spot misconceptions. So if they're writing down and explaining their claim, evidence, and reasoning, you can start to see where's the evidence that they're missing or what's the reasoning that's not going well. Let's look at an earth science example of what it might look like to have students do a claim, evidence, and reasoning writing assignment. And this is a very, very simple one. It's from a great evidence-based unit for earth science. You can find it here. It's free. It's great. It uses Google Earth. And in this case, the question is, do you think the scar, or the thing that they're seeing at the bottom of the Atlantic Ocean floor, is a ridge or a trench? And the student makes a very simple claim. The scar is a ridge. They provide their evidence, which is their data. Because it's negative, this is actually higher than the surrounding elevation, and so they're saying that it is a ridge because it's higher than the two stations on the other side. Very, very simple example, but a good place for students to start. Here's a life science example. This was a student-selected question for a basic lab where they were just examining different types of cells in microscopes. And the student selected the question, what shape are cells? They answered, cells can have lots of different shapes. In this lab, the animal cell was like a wavy circle, the plant cell looked like a rectangle, the bacteria was squiggly like this. Since all these cells have different shapes, I can tell cells don't just have one shape. Once again, a very simple argument. Here's the claim. In the orange, you have their evidence, which is the data that they collected in lab. In this case, it was observation data, and then the reasoning down at the end. All right, let's get a little bit more sophisticated. This is from a lab in which the teacher really wanted the students to notice that levers don't always make work easier. And students came in, they seemed to assume that if there is this tool, there is this simple machine, that it's always going to make things easier. He wanted them to note about the differences with where the fulcrum was located relative to the load. And so this is they've made a claim here. They've supported it. They've talked about the different instances in which they tried the load at different distances and the effort at different distances. And then they were able to use, here's what it's talking about, putting in the science ideas. Doing work is the ability to move an object. If it takes less force, the work is easier. And then it talks about that when the fulcrum is close to the load and far from the effort, the work is easier. And this was a much more sophisticated argument that the student had to think through for a while and probably had to write a couple of times before they do it. And it comes out of this excellent thing. I'm using it with permission from Catherine McNeil, but this is a great article that you can look at how it works out within a science classroom of introducing this and using it. And finally, this is a chemistry example. The question was, is there something solid under the cardboard sheet? If so, what shape is it? This was a Rutherford's atom simulation. They were shooting marbles under a cardboard and trying to simulate what Rutherford did, looking to see if there was a nucleus in the center of the atom, or at some point in place in the atom. And the student made a claim, there is something under there, and they made a second claim later on that I think it's square. And then there's something under there, and here's the evidence. Because some of the marbles bounced back, they would go through if there was nothing there. That's the reasoning. I think it's square because they came straight back on all sides, and we had a square-shaped blank spot on our lab sheet. They were drawing where the marble had bounced. And they could finish out their reasoning right here, which they didn't, but that's okay, with an explanation of how marbles bounce against different shapes. So that's the introduction to the basic idea of claims, evidence, and reasoning. Do you have any questions at this point or comments that you'd like to make about the claims, evidence, and reasoning approach, or about the importance of having students write?
If you've got any questions at all, you can go ahead and put those in the chat.
I'm seeing a question about the title of my book at NSTA. It's Once Upon a Life Science Book, 12 Interdisciplinary Lessons to Help Create Confident Readers, or something like that is the subtitle. And it provides a group of common core-based lessons that can work specifically on reading skills with a little bit of writing skills over the course of a year in a life science class. All right, if there's no other questions, we'll go on and dig into more of the meat of this. Oh wait, here I've got, my students seem to have the most difficulty putting their claims, evidence, and reasoning together to draw a conclusion. Yes, I understand that. And the emphasis on the claim really helps them to get a conclusion, is to go back over and over again. This is your question. Your claim is an answer to your question. And using the word claim sometimes helps them get at what the overall goal is of writing a conclusion. All right, so we'll dig into some of the meat of this, of helping students start to write these things down. The very first thing that you want to do is introduce the framework in some way. And I find that using something like the slip or trip detective activity that we did a few minutes ago is a great way to help students start seeing why they're doing it and what it is you're trying to get them to do. And I usually also begin by talking about why I'm using a claims evidence and reasoning framework with them. I tell them this is how you make an argument or explanation convincing, and I point out that this is what scientists do, which are both things that we talked about a few minutes ago. The next important step in this is to either help students generate or give them a clear question. So it should be very obvious to them what sort of claim they're trying to generate. So if they are designing their own labs for some reason, for some topic, you want to make sure that they're starting with a clear question, either that you're giving it to them or that they're generating as a class a list of potential questions. For example, in that cell lab, the students generated a number of questions that they could answer by looking at different kinds of cells. It was very simple questions, such as what shape are cells, do cells move, what color are cells, what's the difference in a plant cell and an animal cell. They started with that question written clearly at the top of their paper. They gathered their data, and then when they sat back down, the question was right there at the top of their paper, and the instructions were for them to make a claim in response to that question. And then comes pre-writing. And in science, we're not used to thinking about doing pre-writing with our students. We think of pre-writing as being the realm of English teachers, and in a lot of instances it is. But there are some very short steps, not elaborate steps, but short steps that science teachers can take to start their students getting on the right track with a writing assignment. The first set of pre-writing decisions that you need to make for yourself are what are the science ideas that you want to go over with your students. And the degree to which you're going to have them do pre-writing on the science part is going to depend on what exactly your goal is for the activity. So if it's very early in the year, you may want to generate a list of possible claims on the board and have students just select from the claims that you've provided, which of these claims do you think your evidence supports, and have them select that claim and write it down at the top of their paper. Later in the year, you might just say, be sure to make a claim. Then you want to talk about where you will look for your evidence. Early in the year, once again, you're going to have to say over and over again, you just did a lab. Look at your lab sheet. You'll find your evidence in the data portion of your lab sheet. Or if they're not working off a lab sheet, if they're working off something they've read, point them to the paragraphs where they will be looking for the evidence to support what they're going to talk about. Later in the year, once again, just say be sure you're using valid evidence. So you gradually withdraw support and students will start being able to pick up these things on their own. And finally, early in the year again, you may want to look with them at all the pieces of this and talk orally about the reasons that show that this is good evidence, and then just see if they can take what you've been talking about in class discussion and reproduce it on paper to see that they understood the ideas. Later, once again, you're going to be asking them to just say, you need claims, evidence, and make sure you've got good reasons to explain how your evidence supports your claim. Another very useful pre-writing question is, what science words will you want to include? We know that our students are not generally practicing the science words from our classroom in the lunchroom or on the ball field or wherever they go after school. If they're going to practice their science words, their vocabulary, they're going to do it in our class, and we need to make sure we give them plenty of opportunities to do that. So asking before they start writing, what science words will you want to include? And making a list of those possibilities on the board, maybe starring the ones that you want to make sure they include. Or later in the year, not listing them on the board, but simply saying, take a moment to jot down for yourself the science words you want to make sure end up in your writing. Then you want to think about what the audience is. Is the teacher the audience? Are they writing to you? Because if they are, then they're going to expect that there is a certain amount of shared knowledge between you and them. After all, you were there, you were in the room. If they were doing a lab that you told them what to do, well, you should already know what happened because you were there. It's a little more, it's a little easier for them to understand the level of detail they need to give you if they designed their own experiment and they're explaining what happened. But you also can select an imaginary or a real outside audience, someone who wasn't there that day. Write it to a younger child, explain it to your mother. Lots of times coming up with an outside audience helps them get into the mindset of being as detailed as we would like them to be in science writing. And finally, asking this language question. Just before they start writing, say, now wait a minute. Are you going to use casual or formal language here? Simply asking this question helps them recognize that they have multiple language sets. Lots of students haven't thought clearly about the fact that there is casual language and there is formal language and they're different. That they have a casual language that is a perfectly good language that's valuable for speaking with their friends and relatives, and that there's a formal language of school that takes a little bit more work sometimes, but that's important for school and for work. And so it's very useful if you regularly ask them before writing, are you going to use casual or formal language here? And simply having that be asked of them on a regular basis helps them realize that this is something they should be asking themselves when they sit down to write. It's also true that there are times that you may want them to use casual language. For example, students can become quite skilled at trying to throw around vocabulary words they don't really understand, and it can be a good exercise to have them translate something out of scientific type formal language into casual language for a peer or a younger child, and that gets them to think more deeply about the science ideas. But it's a good habit to be in, to ask this question every time you give them a writing assignment, even if the answer is always going to be the same, just so that they get in the habit of thinking about what language group, what language set they're going to use when they're writing. And then we can get into writing words. And this is the sort of thing that on first glance feels like it ought to be the realm of the English teachers. But in fact, there are certain sets of writing words and writing patterns that show up in science in ways they don't show up as often in other kinds of writing. I put the word because here, obviously that's common. But with younger students, you might want to talk about what writing words are you going to use. You're going to want to make sure there's a because somewhere in your writing, depending on whether or not that's appropriate for what you're trying to do. In some writing sets, they may want to use sequencing words, first, second, third, if the sequence matters. Sometimes the sequence doesn't matter, so it's not important that they talk about first, second, and third. Uncertainty words, usually, generally, suggests, indicates. Students always want to prove what they've done, but there are times when it's much more accurate to use some uncertainty words, and talking about times that they may want to use uncertainty words. Therefore is a great word that shows up a lot in science writing. We'll talk more about that one in just a minute. Also, if, then, and however. All three of these we'll look at in just a minute that show up a lot in science writing. I wouldn't throw all of these writing words up at the same time. You should think ahead if you want to introduce a writing word or get them to use some writing words about what you think would be most appropriate for this topic. And then just before they write, say, you know, after you've talked about what science words they want to use, say, you know, there's a writing word you might want to use here as well. Let me just throw this writing word up on the board. Here's a therefore. And therefore can be really useful in a situation like this because therefore connects the reasoning to the claim. So for example, if you had students who had done a common osmosis lab where you've used vinegar to remove the eggshell from an egg, and so you have this globby thing that has a membrane around it and just the egg parts inside. You can drop it in syrup, and because of osmosis, the water from the egg will go into the syrup because the syrup is actually more concentrated than the stuff inside the egg. All right, so you have a student who puts forth, what claim can you make about the movement of water when the egg was in the syrup? And the student puts forth the egg was squished, and in this case she meant smaller. And we got more syrup than we started with. So you say, well, this is a wonderful place to add a therefore. Here is your evidence. We have the evidence. Tell us what your claim is. And we can put a therefore in here because that's going to connect the reasoning to the claim. And therefore, water moved from the egg into the syrup. And if you introduce therefore on a number of occasions, for example, when it shows up in reading as well, notice on the third paragraph on page 12 here that there was a therefore. It helps clue students not just to helping them produce good writing, but it helps them do good science reading. Because in science writing, the word therefore almost always flags an important statement. And if students are reading along and therefore sets off kind of warning bells, alarm bells in their head, it gets them to go, aha, therefore, and then they go into the next sentence and it helps them pay closer attention to what they're reading. And so, therefore is both a good writing word, but it also helps them become better readers. All right? Here's another example. This is where a student used a therefore. There's plenty of other things that can be critiqued. We did this really fun lab. They had the grasshopper, they've dissected it. We didn't try to look at all the different organs in there because it's just, you know, for those of you who've dissected grasshoppers, it's just kind of a globby mess, and technically it's all there, but it's really hard for the students to find. So after we had done a careful examination of the exterior, looking at all the things we wanted them to see, we had them cut inside, and we said, all right, find their bones. Find us a bone. That's what we want you to do. We want you to look inside the grasshopper and find a bone. And they all just gleefully go in there and they're just working. Actually, I usually teach in a learning cycle, and this did not end up being done as a learning cycle because I was working with another teacher, and she had given a lecture the day before on invertebrates and how grasshoppers and insects were invertebrates. Didn't matter. They were in there just looking just as hard as they could to find a bone. And finally, members of each group would slowly start saying, but there's not any bones. I can't find any bones. Where are the bones? And, of course, that was the most wonderful teaching moment to be able to go, well, there aren't any bones, are there? Well, let's see if we can figure out what makes up the grasshopper skeleton. And then we dissected the thigh very carefully, and you can actually see where the thigh muscle connects to the exoskeleton. But we weren't using the term exoskeleton at that point. We were just calling it, we let them call it whatever. The outer covering is the word that we were using is the teacher's. In this case, the student took the word skin, which was fine. We were going to correct it the next day. But his claim was the skin, and of course we would want him to do a sentence, but that's okay. The skin, we looked and there's no bones. The muscle connect to the skin. In people, muscle connect to the bones. Bones are our skeleton. And then here was a beautiful therefore. Therefore, skin is their skeleton. And with all the other writing problems here, you can still throw this up on the overhead and say, here's an excellent use of a therefore, and let students see how this can be a very useful writing word. And you can think about how therefore is a word that shows up in science in ways it's not showing up in the things that they're reading in their English class. And there's a reason that science teachers need to be the person who's talking about the word therefore. All right. If then is another really good science pair. It helps you say what you would predict to happen. So in this case, he's written, there is something under there because some of the marbles bounced back. This is the example that we looked at earlier with the simulation of looking for the nucleus in the atom. He says they would go through if there was nothing there. And this is a great chance to show him that a more scientific way of saying it would be if there was nothing under the cardboard, then the marble should go straight through. If and then are often paired with a however. If, in fact, the if-then plays out, then you can say it did play out, therefore, but often it plays out with a however. And this is a good way to talk about counterclaims. And so you may be doing a lab where you're looking at two possibilities, and you want to talk with your students for just a moment before they write about how if and then can help them express why their evidence shows that something is not true with an if, then, and a however. All right, so there are kind of 4 stages of pre-writing that I talked about. Helping students think through their science ideas, having them list science words to include, considering the audience and or the formality of their language, and considering a writing word or two that they might want to include. As you think about yourself going to teach your class, going to have them do a writing assignment maybe after a lab, an argument, put in a mark. What are the things that you could actually see yourself doing? I'm seeing lots of things coming in on helping them think through their science ideas, having them list the science words. Pretty dense in considering audience and formality of the language as well. And actually, I'm really pleased to see how many of you are interested in the idea of talking about writing words. That's the thing that is the hardest in general for science teachers, because we didn't come through schools prepared to talk about writing with them. Is there anyone who's hesitant to address one of these things that would like to throw in a comment about why they might feel hesitant about it? All right. And then another thing to do when you're helping them learn to take on claims, evidence, and reasoning is that after they've tried it, because you don't want to front load them with too many things, and of course even talking about writing words they might use is something you probably want to save until after they've done some claims and evidence writing a few times, so they've gotten a chance to get the basic ideas of thinking about claims and evidence and reasoning down a little bit more, is that you might want to take a look at strong and weak arguments with the class after they've written something. I love to use strong arguments from the students, if there is one, or a conglomerate if I have to make it out of several students' work. I usually try to make up the weak arguments because that obviously can upset students. Here is a comparison. Do cockroaches prefer light or dark environments? And you'll see here the kinds of comments you're likely in this weaker one, the kinds of comments that you're likely to get from students who are first experimenting with claims, evidence, and reasoning. So they make a claim because they're good at claims. Cockroaches prefer dark environments. But then they just launch off. They want to hide from us because cockroaches have those long antennae. Maybe they can just feel their way around and don't need light to see. And that's something that's really common with students, is that they just, it doesn't matter that they have this beautiful set of evidence right in front of them. They just start talking about essentially other hypotheses about what might be going on. But of course, what you want them to see is that they need to pull from their data. Cockroaches prefer dark environments. We let 10 cockroaches choose between the light and dark side of a box. 9 of them chose the dark side. Since more roaches chose the dark, we can tell that's what they prefer. Then after they've done some writing, you've looked at strong and weak examples, you find yourself with evaluation. And this is another place that science teachers often have a hard time, is that English classes are often kept small, especially writing classes may be kept small because the teachers are expected to deal with these large piles of papers to read. And you can have the same issues when you suddenly start having your students do more writing. And so I want to go ahead and address that on the front end before you find yourself kind of overwhelmed. It's important that you think ahead about not getting overwhelmed with grading. And the first thing is you probably already have them doing a lab report. So if you replace that lab report or some portion of it with a section in which they write about claims, evidence, and reasoning, then you're essentially just substituting some post-lab questions, substituting this for some post-lab questions that you would be grading anyway, and so you can just sort of make an even exchange. If you're having them do some writing in class that you might not have had them do normally, you don't necessarily have to grade it. You can just quickly sort it by levels of organization, levels of understanding. So you can make piles of, this student got it, this student got it, this student got it. That one I really can't tell from what they said. They're going to need to write a little bit more, and boy, he's off, he's off. And you can quickly have 3 sets of papers in front of you that you can use for your own feedback of what needs to happen next, even without actually giving them a grade. You can have a rubric. We'll look at one possible rubric in a few minutes, and that you can quickly mark. Or after they've done this a couple of times, you can start having them do peer review and self-review using a simple system or a rubric. So you can give them the same rubric you might use to grade it, or you can have them trade with a friend and say, use the green crayon to underline your partner's claim. Use the orange crayon to underline their data. And then make a smiley face if the data supports the claim and a frowny face if it doesn't. And then underline their reasoning and write a 1-sentence response to whether or not you think the reasoning supported adequately linked the evidence to the claim. You can do all of that. The students get some feedback. They get some practice, extra practice thinking about it. And it doesn't have to be a grade, or it can be a check-off if you need it to be a grade, simply to motivate them to actually complete the assignment. And keep in mind that students learn writing by writing. You learn to write by writing, and some of that writing can just be practice. It might make students frustrated because they think everything that they do needs to be for a grade, but there are times that it's valuable just to write and to get that practice, and you grow in writing by writing, even if you don't get a grade or feedback on it. And so be comfortable letting students, some of their work be just for practice so that you don't get overwhelmed with grading writing. All right, here is a sample grading rubric. It's from that CE3 curriculum, but it's that I showed you a minute ago, but it's just a generic, here's the claim, makes a claim, inaccurate claim, incomplete, complete and accurate, the evidence is appropriate or not appropriate or sufficient, and does not provide reasoning, inappropriate reasoning, etc. So it's just a very basic sort of rubric. You can access it from that same link, and I'll give that link again at the end for the CE3 curriculum. All right, we're at questions. Questions about implementing claims, evidence, and reasoning, questions about pre-writing or writing, or comments. And I see some comments coming in over here on the chat, and I'll check on those while I'm at it. Let's see. They want points for everything, so I give points for practice too. Yes, just calling them practice points and leaving it at that, and then they don't feel such a need. Good. They don't feel a need for you to give it back for a grade because they got points on it, is what I meant. Yes. Questions? All right, you're saying I'm at the website and I don't see the rubric. Is this the website for the CE3 curriculum, or is this the website for the CE3 curriculum? It may be in the materials. You register as a teacher, and then they give you access to all kinds of stuff but they do something to, I forget exactly what it was that you have to do to sort of show that you're a teacher, and then you get access to all the teacher materials that they don't want the students to be able to go online and get hold of. All right, so here's the big question. How do I find time to include writing with the millions of standards I'm required to cover? Yes, I understand. And my hope is not that you would not add writing on top of everything else you're doing, but that you would make some substitutions. And the substitutions would be that the students are, I assume in your class you're having the students process their new information in some way. You may be having them answer questions from the back of the chapter. You may be having them, I mean, surely you're doing some kind of lab reports, for example. And so whenever you can, if you can substitute writing for something that hasn't been your strongest, you know, there are lots and lots of good activities, but all of us as teachers have some that are weaker than others. And one of the real values of the writing is it's not just writing for writing's sake. It is writing for learning because of those things that we talked about at the beginning, that the writing holds the ideas in place long enough for the students to think. So they write down an idea and then they're looking at it and then they're figuring out, well, what is the next piece that goes with that? And there's lots of good research that when students are working out relationships between complicated ideas, when they're writing about it, they actually learn that material, that science material, much better. So the writing is a writing to learn. All of this is about writing to learn, and writing to learn the science specifically. All of this goes with your science content. So you're not, except for maybe one instance where you're introducing, you know, something with a silly, like slip or trip, kind of like the little crime scene we did at the beginning. All of this writing is going on about the exact topic that you're teaching on. All right, let me scan over what's being said here. Right, it is in the Common Core. And partnering with a language arts class can be of value. I mean, one thing that can happen is that you can do the initial, you can partner with a language arts teacher, you can do a lab, they write about that lab, and then they take that writing to their language arts class where they work on editing it into a formal piece. Yes, reading the science-based journal articles and having students take a position. And looking at some of those science-based journal articles is another place to point out where some of those writing words are used. Once again, with the idea that it also strengthens their reading. That when they come to realize that if, thens, and howevers are important in the structure of science writing. I see that kind of structure frequently when I'm reading accounts of science research. And particularly just like students tend to miss when they read a multiple choice question that says, which one of these does not belong? And they pick something that does belong, that they will gloss over the however when they're reading. And of course, in science, having a however is a really important word. And that if they've written with a however, then it will flag for them when they're reading of, oh, I've got to understand something here is not what they thought would happen. Good. Other questions or comments? This is really a strange format where I'm reading things that you're saying and I'm answering in speech. All right, then I'm going to move to our next set of ideas, which is to look back at this Common Core. And this is writing arguments focused on discipline-specific content. And this is really important, that within different science disciplines, our arguments are different. And a lot of life science arguments, for example, are going to be based on controlled experiments. But a lot of earth science, a lot of paleontology type arguments, there's going to be elements of the controlled experiment, except you're going to be looking, maybe comparing how dinosaurs' skull shapes compare to living animal skull shapes and what that might tell us about the dinosaur. And so it's a very different sort of argument. And so this is one of the reasons why the discipline-specific arguments are so important. So once we looked at the Common Core, that we want them to have claims and evidence, and when we get into grades 9 and 10 and then into grades 11 and 12, there's a lot more on counterclaims here, establishing the significance of claims and alternate or opposing claims. So a lot more thought about not just the claim and evidence that you're providing, but also what does the other guy say and why is he wrong? And that sort of argument is also very common in science when there are several competing hypotheses for why something might be true, and there's a lot of back and forth going on in the scientific literature. They're doing a lot of saying, so-and-so says X and such, and here's why they're wrong. And so here is our science whodunit for the night. We started with a mystery. And this is a historical science whodunit of who or what put maggots on the rotting meat. This is a common life science example, Francisco Redi versus spontaneous generation. For those of you who haven't seen this in a lot of years, if you're not coming out of life science, the maggots, they wondered why. Let me start over. Fly eggs are very small and they're very hard to see. So what people were observing was that they would have some rotting meat, and shortly thereafter it would develop maggots. And they knew enough to know that maggots developed into flies. And so the idea arises that in fact the meat itself created maggots, which then turned into flies. And so there were recipes out there in old books of here's what you do if you want some mice. Here's a recipe for how to make mice, and you would put some grain sacks and some food and so forth, and you could get mice to grow, and you could get flies. If you would put out some rotting meat, it would generate some flies for you. And Francisco Redi comes along, and among other scientists, saying that he thinks life only comes from other life. And in this case, flies only come from flies. And so he sets up an experiment in which he has one open flask with some rotting meat in it. He has one sealed flask with some rotting meat in it. And he has one flask with galls over the top so that air can get in and meat cannot. Because part of the argument at that time was that air had a factor in it that could help produce life. And so he had to make sure that there was one flask in which air could get in but not flies. Yes, and yellow jackets coming from a soda can during a picnic. Exactly. That was from over on the chat. All right, so we have a claim, and in this case we actually have two competing claims. Can I get somebody we'll try this. Raise your hand, which is the third little icon up at the top. Somebody to raise their hand who will put in a claim for us. All right. All right, Kristen Rikers is going to take a text box and put a claim in. Can I have somebody put in a counter or competing claim? There's actually 2 of those. Can I get a volunteer for that? Either competing claim would be fine. No takers on that. All right. Well, Kristen, you go ahead and put in the claim, and I'll put in a counterclaim. If I can. You take your text box, and there were 2 competing claims. One of them was, I see you, Kristen. You got it. Oh, Kristen, you're giving the claim that Redi is going to make with his experiment. So I think you don't want that the flies are coming from the meat. I think you want flies coming from somewhere else. Oh. Okay, no, it's okay. You're fine, Kristen. I'm sorry. Here, I'll throw in this was a little more complicated than I realized it was going to be. Let me try putting this in here, and we'll get, Redi is going to argue from his experiment that flies come from other flies. And there we have it. Flies come from other flies. Flies come from rotting meat or rotting meat in air. All right. So this is an example of where you don't actually have to have students do an experiment. You can give them a task based off some diagrams they've looked at, some reading they've done, some class discussion that has happened. In this case, you could give the assignment, you're Redi. You're Francisco Redi. You're addressing a group of scientists familiar with this debate, and you need to make a claim, evidence, and reasoning, and then you need to talk about the counterclaims, the evidence against, the reasoning for the evidence against. And then with a long writing like this, it's often good to have students pull in a summary statement. I mean, long relative to, this isn't really that long a writing, but relative to just making a simple claim and supporting it with evidence. All right, so this will be a little easier technologically, I think. You can come over and there is a place you can get the pen. And can I get somebody who can underline the claim here? All right, Alan, underline the claim. Perfect. Flies come from other flies. Excellent. Now, can somebody find the counterclaim in there? Oh, I hear a hand. All right, Teresa, great. And while Teresa is figuring out how to use the pen, okay, yes, those, I think you're trying to get, those who support spontaneous generation would say that rotting meat alone or in combination with air creates flies. Excellent, there's our counterclaim. All right, let's get our evidence in support of the claim. Can I get a volunteer? All right, Christine. Oh. All right, I'm seeing evidence against the counterclaim. Good. All right, here's our evidence. And notice the if-thens. If rotting meat in combination with air could produce maggots, then there would be maggots in flask 3, which allowed air but not flies. That's actually our reasoning, but that's good. That's important. The evidence here is that neither of these flasks had maggots. And then our evidence up here, can I get evidence for flies only come from other flies? Get a volunteer on that one? We're going to have this thing so marked up. At this point, maybe I should just do it because it's getting very marked up. All right, I'll take this. And so here was our first, there we go. Evidence for flies only come from other flies is the maggots only formed in the first flask. Here is our little bit of scientific knowledge. The flies could land on the meat and that the flies make the maggots. And then we have our nice reasoning down here with the if and then, and the however, and then a beautiful therefore at the end. And that's what it might look like if you had students doing claim and counterclaim with evidence for, evidence against the counterclaim, and reasoning. Good work. Thank you. Big applause for those people who stepped out and, nope, I raised my hand. I was trying to clap. Let me try again. Big applause for the people who stepped out and jumped in on that one and the last one. That was hard. All right. And one thing I want to, I put this in here so to note that the 11th and 12th grade standards, which talk about the importance of the argument, they would also want the writer to position this within the larger argument of spontaneous generation. That's really a sophisticated piece of writing that we would be asking 11th and 12th grade students to do. And at some point you have to make the determination of how far along your 11th and 12th graders are in this process of whether or not they're ready for that. But that would be what you would do, is you would position it within the larger argument of spontaneous generation. All right, if you would like further information on some of this, this is the article that I took an example from her earlier on levers. The lever example is actually not in this argument. It's one that she shared with me, but talks about, that comes from that same classroom that is described in this Science and Children article, which is a really nice look at what it looks like with older elementary school students to do, and really middle school, because a lot of what you can do at older elementary versus middle school just depends on how strong their background is when they get to you. A lot of times middle school students in some places are doing what upper elementary school students are doing in others. There is a webinar archive from last week. This is the book that I used to take the slip or trip idea out of. It's teaching argument writing. It's very specific on the writing. It gets into a lot of detail on writing. He's actually an English teacher. And then this was the curriculum that I talked about earlier. Right, final questions or comments about counterclaims or on anything else that we've discussed? Well, I'm not seeing anything coming in. Liz, what do we do now?
All right. Sorry, my voice is just about gone. We'd like to thank Jodi for presenting for us this evening. We'd also like to thank the sponsors of today's program, the New Science Teachers Academy, Amgen, Astellas, Bayer USA Foundation, American Honda Foundation, and Dow. Thanks also to the administration of NSTA for their support. Here's a look at our upcoming calendar. We've got weather and climate with satellite meteorology on December 13th. That's tomorrow. On the 17th, chemistry of water, Mars exploration. Is there water on Mars? And also on the 17th, a question, claims, and evidence, the importance of place of argument in science writing. You can register for these webinars at learningcenter.nsta.org, which I'll post in the chat in a moment. We look forward to seeing you again on another NSTA web seminar. Thank you, everyone, for your participation.